Welcome to the program elective course on deep learning. Before going into today's session, let me acknowledge that the contents of today's presentation are taken from the NPTEL Deep Learning courses by Professor Mitesh M. Kapra of IIT Madras and Professor Prabir Kumar Biswas of IIT Kharagpur. Some of the contents of this session has been taken from the sources available in the internet. The textbooks prescribed for this course are Deep Learning by Ian Goodfellow and Yoshio Bengio, Deep Neural Networks and Deep Learning by Agarwal, Fundamentals of Deep Learning, Designing Next Generation Machine Learning Intelligence by Nikhil Biduma and Nicholas Lecosio. So let's go directly into our course, Deep Learning. As you all know, deep learning is a recently emerged branch of machine learning, particularly designed to solve a wide range of problems in computer vision and natural language processing. In this course, we will be discussing the building blocks used in deep learning like neural networks, deep neural networks, convolutional neural networks, and recurrent neural networks. Various learning, optimization and regularization algorithms will be discussed in this course. The application and research area of deep learning will also be seen in this course. So before going into deep learning, let's see what is actually learning. So we all might be learning a lot of things from the time we have originated in this world. The first pattern that we all might have recognized may be the face of our mother or the person who has taken care of us. Later, we have learned so many patterns that exist in the world around us of both living and non-living things. So, in the learning process, what really happens is that we capture the information or the descriptors from the signals that we receive from the real world around us. As humans, we receive these signals through our sense organs, and these signals can be visual signals or auditory signals. In the case of visual signals, the information or the descriptors that we capture may be the shape of the object and the information regarding the region of the object like the color, texture, intensity, etc. And from the limited knowledge that we have regarding a neuron, we have understood that neurons are the basis of the nervous system, which is made up of brain, spinal cord, and peripheral nerves. The neurons form nerves and the nerve fibers that spread throughout the body. They help in establishing the internal communication. The neurons actually consist of various parts, and dendrites is one such part that receives signals from other neurons. Synapse is a point of interconnection between two neurons. Soma is the place or the center where we process the information. Axon is the part through which we transmit an information from one neuron to other. So, in the case of generating a response, we can see that the sense organs interact with the outside world. They pass the information to the neurons, and these neurons may get activated, which actually produce a response. And we have to understand that it is not a single neuron that actually produces the response, but we have a massively parallel interconnected network of neurons. And the sense organs pass this information from the sense organs to the neurons that are present in the lower layers. Some of these neurons may fire in response to this information, and they pass this information to the neurons which in turn are connected to them, and eventually a response is produced. So in an average human brain, there is approximately 10 raised to 11 neurons or 100 billion neurons. And from the knowledge that we have acquired regarding the information processing that happens in our brain, we understood that there is a hierarchical processing that happens in our brain. When we receive a visual signal through our eyes, there are several layers in the brain that actually process this information, and in the layer 1, uh, this layer 1 dictates the edges and the corners of the objects or visual signals that we have perceived. The layer 2 group these edges and corners and form certain parts of the objects or recognize the parts of the objects, and layer 3 consolidate all these parts and recognize the object as a whole. So hierarchical processing happens inside our brain. Now, artificial intelligence is a buzzword, and we know that artificial intelligence refers to the development of systems and technologies that can perform tasks a typical human being can perform, like solving problems, making decisions, recognizing patterns, learning new things. And artificial intelligence uses machine learning and deep learning as a core methodology to achieve this. So if we look at artificial learning, we can see that it is a technique which enables machines to mimic human behavior, and machine learning is a subset of artificial learning technique or artificial intelligence technique which use statistical methods to enable the machine to learn and improve from its experience. Whereas deep learning is a subset of machine learning that uses multi-layer neural networks to make computations feasible and to mimic the human behavior. So a deeper vision of artificial intelligence shows that we can use this artificial intelligence in various areas like natural language processing, visual perception, automatic programming, intelligent robot, knowledge representation, automatic reasoning, etc. And the artificial intelligence uses various machine learning algorithms like linear and logistic regression, k-means clustering, support with vector machines, k-nearest neighbor, decision trees, principal component analysis, random forest, etc. to achieve this goal. And we have also come across various neural network concepts and deep learning concepts. In neural network concepts, we have developed Boltzmann neural networks, multi-layer perceptrons, and in deep learning concept, we are using various architectures like convolutional neural network, recurrent neural network, generative adversarial network, and deep belief network to mimic the human behavior. So if we look at the difference between machine learning and deep learning, we can see that in machine learning, from the input, we will be extracting the features, or the features will be manually extracted, and these handcrafted features will be fed to machine learning algorithms so as to perform the classification or regression, and the output is produced. Whereas in deep learning, we will be providing the input as such. The raw input data will be provided, and using various deep learning architectures, we will be extracting the features as well as doing the classification as well as the regressions, and the output will be produced directly from the raw input that we are providing. So artificial neuron is a fundamental unit of deep neural network, and we have derived inspiration from biological neuron or neural processing units in our brain to develop this artificial neuron. And the first simplified computational model of a biological neuron was McCulloch Pitt Neuron, that was introduced in 1943 by Baron McCulloch and Walter Pitts. This McCulloch Pitt neuron laid the foundation of modern neural networks and artificial intelligence. This model abstracts the functioning of biological neuron into mathematical framework that process binary inputs and produces binary outputs. So the McCulloch Pitt neuron is a binary model, and it takes multiple inputs and produces binary outputs based on a threshold function. So here we can see that in the case of a McCulloch Pitt neuron, we are receiving inputs in the form of x1, x2, xn, and these inputs can take values either 0 or 1. That means it can take binary inputs, and these inputs are provided to a processing unit This processing unit performs two functions. One is the summation of the inputs that are provided to this processing unit, and next is an activation function. And this here, the activation function is a simple thresholding function that is applied on the summation of the inputs. So there are two functions, g of x. The x is the feature vectors or the inputs that are received, and using this function we perform the summation of the inputs or input vectors that are provided to this processing unit. So g of x is given as sigma I is equal to 1 to n x of I, and another function that is performed on another function is performed on g of x, and that function is an activation function. So f of g of x, and f of g of x produces the output, and this f of g of x is equal to 1 if the g of x is greater than or equal to theta. Theta is a particular threshold value, and f of g of x is equal to 0 if g of x is less than that threshold value. So in McCulloch Pitt neuron, usually weights are not associated with the inputs. We are feeding the inputs directly to the processing unit. In McCulloch Pitt neuron, the output is determined by comparing the sum of the input activations to a predefined threshold. And we can see that if the sum exceeds the threshold, its output is 1, otherwise the output is 0. So the McCulloch Pitt neuron does not have a learning algorithm associated with it. That means its behavior is fixed and we cannot modify it through training or learning from the data. So we can see that McCulloch Pitt neurons can solve only linearly separable problems. So what is this linearly separable problems? That means, for example, if we take an OR function of two input values x1 and x2. So in the case x1 and x2 are allowed to take values only from the set 0 or 1. That means x1 can take the value either 0 or 1, x2 can take the value either 0 or 1. And if we are performing an OR function on this values, we can see that we get an output of 0 only when x1 is equal to 0 and x2 is equal to 0. And in all other cases, the output will be 1. That is, when x1 is equal to 1 and x2 is equal to 0, we get an output of 1. When x1 is equal to 0 and x2 is equal to 1, we get an output of 1. And when both x1 and x2 are zeros or ones, we get an output of 1. So in 3 cases, we get an output value of 1, whereas in 1 case, we get an output value of 0. And if we plot this output values in a 2-dimensional space, we can see that we can draw a line to separate the set of similar output values. That is, 3 similar output values will lie on one side of a line, and the single output value of 0 that we got will be lying on the other side of the line. So it is possible to have a line to separate the values that we produced as outputs. Similarly, if we are doing an AND function, we can see that in 3 cases we get an output of 0, and in a single case we get an output of 1. That is, when the inputs of x1 and x2 are 0, 0, 1, 0 and 0, 1, we get an output of 0 in the case of an AND function. And when both the inputs x1 and x2 are 1, we get an output of 1. So again, when we plot the output values in a 2-dimensional space, we can see that a single line or a line can separate similar output values to one category and similar next output values to another category. So the output values of a particular value will be lying on one side of a line, and the output values of another value will be lying on the other side of the line. So it is possible to have a line, a linear it is possible to have a line to separate the set of values. So such a problems are called linear separable problems. And McCulloch Pitt neuron, if we look at McCulloch Pitt neuron, we can see that we can implement an AND function, OR function, as well as a NOT function using this McCulloch Pitt neuron. So all these functions are linearly separable functions. And in the case of an AND function, the threshold value that we set will be equal to 2, and that is the summation of the inputs must be greater than or equal to 2. And in the case of an OR function, the summation of the inputs must be greater than or equal to 1 to have an activation of the output and produce a result of 1. So what are the limitations here we face? So in McCulloch Pitt neurons, we can see that we are actually providing binary inputs. So what happens if we have a non-Boolean inputs or real valued inputs? And in McCulloch Pitt neuron, we are actually hand coding the threshold value, or we are setting the threshold value. We are not assigning any weights to the inputs. So what if we want to assign weights to some inputs? So what do you mean by assigning weights to some inputs? Suppose while you have chosen to study deep learning as your elective. So what may be the criteria that prompted you to take this deep learning as your elective course? So one of the criteria may be the interest you have in this deep learning course. Another criteria may be the syllabus that you have checked and found that it is not so complicated one. And the third criteria may be the resources available or the resource person who is taking this course. So that means 3 criteria you have assigned, and you may be assigning different importance to different criteria. For example, you are considering that selecting this course is important because you are more interested in this. That means more weightage is given to this criteria. Likewise, for every input that we are providing to the artificial neuron, different weights may be assigned, and in that case, what we have to do if we have to assign different weights to the inputs. Now, what we have to do if the problems are linearly not separable? So in that case, a new concept was introduced, a new idea was introduced by Rosenwald, an American psychologist, which is called a perceptron model, and in 1958. Later it was refined by Minsky and Papert, and they introduced numerical weights to the inputs, and they also introduced the concept of accepting real values as inputs and also weights associated with the inputs. Then this neuron, perceptron, produces binary output just like McCulloch Pitt neuron. And another important feature of this perceptron is that it employs a learning algorithm or perceptron learning rule, which iteratively updates the weights based on the error correction. So the conventional perceptron or single layer perceptron can only solve linearly separable problems. So here in the perceptron, if we look at the schematic diagram of perceptron, we can see that we are feeding input features or input feature vector to this perceptron. So the input feature vectors are x1, x2, dash 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 xn. Associated with each feature vector, we have a weight, that is w1, w2, etc. to wn. So the output that is generated by this perceptron is y, and the y can take 2 values, either 0 or 1, and the y takes a value 1 if the summation of the weighted inputs is greater than a particular threshold theta. That means in the perceptron, we have a processing unit. The processing unit performs 2 functions. One is the summation of the weighted inputs, and the next is an activation function. This activation function here we are considering is only a threshold function. So the output is produced after this activation function on the weighted inputs. Sum of the weighted inputs. So y is equal to 1 if sigma is equal sigma I is equal to 1 to n, Wixi is greater than or equal to a threshold theta, and it is equal to 0 if summation of I is equal to 1 to n Wixi is less than that theta. Rewriting this equation, we can have another equation y is equal to 1 if sigma I is equal to 0 to n Wixi minus theta greater than or equal to 0. So we have brought this theta on the right hand side of the equation to the left hand side of the equation. So and y is equal to 0 if sigma I is equal to 0 to n Wixi minus theta less than 0. Now again, having a more conventional equation for this equation that we have written on the right hand side, we can have y is equal to 1 if sigma I equal to 0 to n Wixi greater than or equal to 0. So we have included this minus theta also as part of this weighted inputs. So there, in order to include this minus theta as a part of weighted inputs, we have introduced a new input to the processing unit, where this input is represented as x0 and will be taking a value of 1. We have introduced a new weight value w0, which will be taking a value of minus theta. So this w0 is otherwise known as the bias. It represents a prior knowledge or the prejudice that we have regarding the system, and the weights and the bias will depend upon the data. They are learned during the training process of the neural network using various optimization algorithms like gradient descent, and the weights and the bias are typically initialized with small random values before we start the training, or it may be initialized with some specific initialization schemes like a Xavier initialization or He initialization. And so after initializing these values with some random values, after initializing this weight and bias x0 and w0 with some random random values, we will be providing the feature inputs also to the perceptron, and we will be starting the training of this perceptron. So the perceptron can be represented schematically like this. These are the input that we are providing. The inputs are actually features, and this feature vector, in the case of an perceptron, this input layer simply passes the inputs to the processing unit of the neuron, and while passing this inputs, a weight will be associated with each of the input feature vector, and so x1 will be associated with a weight w1, x2 will be associated with a weight w2, and similarly xn will be associated with a weight wn, and the weighted sum of these inputs will be calculated first, and then an activation function is performed on this weighted sum of the inputs. And in a simple case, the perceptron will be using a threshold function as an activation function. That means if the weighted sum of the inputs is greater than a particular threshold value, the perceptron will produce an output of 1, and if the weighted sum of the inputs is less than a particular threshold value, it will be producing an output of 0. So this is all about the perceptron in this session. In the next session, we will be discussing with various threshold functions, and then artificial neural networks like single layer neural networks and multi-layer neural networks or multi-layer perceptrons. So thank you.